So, good evening. Welcome back once again to you all. Today, in this presentation, I am going to explain what are the rules that are there to find out the transfer function of a given control system. Rules. We will see the rules in this. This is our lecture 5. Okay. Rules to find out the transfer function or the overall transfer function of given control system. Okay, rules to find out the transfer function of a given control system. What are the rules? So rule 1, rule 1, rule 1. In rule 1, it is very simple rule actually. If the in the given problem, if there are the blocks in cascading, means one block is followed to the another block, then what is the equivalent block we can write? So that is nothing but the rule 1. Let us say in rule 1, for example, you have this is one block with gain G1 followed by another block. This is, let us say, G2. Okay, so this is your input, this is what your output. Okay, if it is given like this, there are two blocks given, G1 followed G2, then what will be the resultant? Resultant is nothing but, as these two blocks are in series, or you can say in cascading, the resultant will be just product of gain, that is G1 into G2. That's all. This is your input, this is our output. Okay, this is your input, this is our output. That's all. So if the two blocks are given G1, G2, then it will be simplified, it will be reduced to a single block. Then the overall gain is G1 into G2. That's all. That is the first rule. Because in last lecture, that is lecture number 4, we have seen the introduction about block diagram reduction. So in block diagram reduction, we have to reduce the number of blocks. We have to reduce. That's why here two blocks are given. We are reduced like this in a single block. Then it will be like this. This is your rule number 1. Okay. Next, rule number 2. What is rule number 2? Rule number 2. What is rule number 2? So rule number 2 is nothing but, this is we already covered either knowingly or unknowingly about this rule in our first or second session. We have studied about the closed loop control system now, with positive feedback as well as with negative feedback. So in the given block diagram, otherwise in the given problem, sometimes you may have the possibility of having the closed loop control system with either positive feedback or sometimes with negative feedback also. Then you have to eliminate that, you have to reduce that okay. Then that is also comes under another rule. It is simply, if in the given problem, if you have this type of same whatever we have studied in our last sessions, this is your okay G, let us say this is your output, this already you know, or RFS sometimes, or you can write no problem. Okay, let us say it is minus, it is always plus. This is the, there is a possibility of having this type of thing also in the given problem. Then what is its equivalent, what is its equivalent? Then okay, means this is the closed loop control system with the negative feedback. Then you can simply simplify that as, finally you can simply write in this way, that is simply it is G by 1 plus G into H. This is your R of S, this is whatever C of S. That's all. This is simplification. Okay, the total block you have to reduce in a single block. How? We already derived this, no? In last session I have explained that what is the ratio of C of S by R of S. Okay, then what is the result? This is the result. Therefore, eliminating of this negative feedback loop as a this one. This is what your second rule. Okay, the second rule is nothing but that is the feedback loop with negative control system with negative feedback. That is your rule number 2. Now coming to rule number 3. Rule number 3. Okay, next see rule number 3. Rule number 3. Rule number 3. It is also similar to this one. Let us say this is your K. Okay, this is your feedback element H. Okay, this is part of output you are giving. This is your C of S, this is your R of S. This is with positive feedback, this is plus. Let us say this is input is always plus. If in the given problem, if you have this type of combination, then you can simplify it as, you can be reduced as like this. So you can write, you can reduce this entire as like this. Have you remembered, no? So this is nothing but this is the control system with positive feedback. Then what is your answer? G by 1 minus G into H. This is your R of S and this is your C of S. This is the rule. So you have to minimize this, you have to reduce. This is what reduction or simplification, you can say reduction or simplification. Okay, so this is rule number 3. Next, rule number 4. Rule number 4. Rule number 4. Okay, so this is another important rule. Basically, sometimes in the given problem you may have, let us see, I will draw first, then I will explain. This is gain. Sometimes this is plus. Sometimes there is a possibility of having summer point, means this is called summing point. This is very important, please note down. This is a summing point. This is called your this particular is called summing point. Summing point. Summing point in the sense, so this is your R, this is nothing but your input basically. You can write your R of S here. This is what your obviously C of S. Sometimes in the given problem any summing point is given, this is before the block. Now if I want to move this summing point after the block, means just I want to shift this point to after the block, just I want to have this summing point from here to this after the block, then how it will look like? How will look like? Means summer means always 2 inputs or 3 inputs comes to this summer. Otherwise sometimes it is called as comparator, or also called as error detector. There are many other names, right? Okay, at present you simply remember that it is a summing point or summer. It sums, means here 2 signals, so this is R of S is okay, always it is there, and this is another, let us say this is some another signal, some X or whatever it is, some signal is coming here. Okay, then just I want to shift to the after the block, then simply how it look like, so it look like this. Okay, see carefully, this is the rule. So means that in equivalent there should not be summing point before the block, you should represent this block after G only. That means like this, so like this only. So here gain will be there, okay, and your summer will, you must show your summing point here. Okay, so your R of S obviously it will be here only, your G will be here only. Then what happens here, no, if you put that summing point after the block, means after the block, then it, so how it comes, you know, same G comes here. That's what, just you remember that. It could be either plus or minus, whatever it is, either plus or minus, this could be plus or minus, whatever it is, no problem, no problem. So simply you remember that if the summer is there before the block, this is the block, this is the block, we have one summer before the block. Now I want to shift that summing point after the block, then in the simplification you write as it is, but in this summing point here G will comes, this gain it will comes here. That is what, that is rule number 4. This is the one simplification, that is what your rule number 4. Now let us see rule number 5. What is rule number 5? Let us see rule number 5. Rule number 5. Rule number 5. What is rule number 5? Okay, in rule number 5 you write same. So in this case, for example the gain is given here and you have summing point after the block. Okay, this is your R of S, let us say this is your C of S. Okay, this is plus obviously, and let us say this has something X or whatever it is, there's something, this is the summer or summer point, where you have actually in the problem if you have after the block. Okay, now I want to shift this summer point, I mean before the block, I want to shift this from here to just before the block, because in the given problem, as per our convenient, we have to apply these rules wherever is applicable. Okay, by seeing the problem as per the applicability of the rule, we have to do this adjustment while solving the transfer function. Okay, if in the given problem, if this type of combination is given, then we simply either we have to move or shift the summer point before the block or after the block as per these rules. In this case, it is exactly opposite to the rule number 4, what we have seen just now. In this case, what you will write? So, obviously this summer point you have to represent here in the simplification. Means in the simplification, you just write like this. You write summer point and you write gain here. Okay, this is what your G, and this is obviously your C of S will be there, and however this is R of S will be there, and here this is plus, and here how it comes, it comes 1 by G, 1 by G, remember that 1 by G. Okay, 1 by G, remember that. So in rule number 5, if we shift the summing point before the block, okay, so you shifted from here to here, then in the feedback here it comes like this 1 by G. That's all. This is rule number 5. And similarly we see the next rule number 6. Rule number 6. So in this rule number 6, for example, if you have in the problem, if you have this type of combination, this is C of S, this is your R of S, and let us see here you have something. Let us see, this is what I am showing. Likewise, what is this? This point is called take off point. If you have this type of points, that is called take off. Okay, take off points, that is called take off point. Earlier is the summer point, this is called summing point or simply summer. This point now is called, this point is called as take off point. So if you want, this is the take off point. If we want to shift this take off point to the after the block, how this will happen, how this will be simplified, means that, so this point should be represented after the block in the simplification, means that directly you show here like this. It is gain is there, G is there. Okay, then this is your R of S, this is your C of S, is it? Then this is the gain cutoff, your takeoff point. No, it is exactly opposite to the summer point. So in summer point, what we have seen? G. Okay, so if it is summer, then if you shifted the summer to the forward, after the block, so how it came? Exactly G, whereas here it comes 1 by G. That's all. So these two are opposite to each other basically. Likewise, you have to remember easily. So this is your rule number 6, means if the takeoff point is there before the block, if we want to shift this block to the after the block, if you want to shift this takeoff point after the block, then you have to represent in this way. This is the simplification. Likewise, you have to show. Similarly, next rule number 7. Let us see. Rule number 7. Rule 7. What is rule 7? Rule 7 is nothing but exactly opposite to this rule 7. Opposite in the sense, say for example, if you have the gain and in this you have takeoff point after the block. You have takeoff point after, let us say all this is some x, nothing wrong in this. Simply we have to focus either it is summing point or otherwise takeoff point, that's all. And one more thing is it before the block or after the block? This is okay, summing point, takeoff point. This is your takeoff point. This is given, actually this is the takeoff point. Now what I should do, I have to shift this takeoff point where this is before the block. Before the block, I want to shift before the block. How it will be represented, how it will be reduced, means that you have to okay, show the block, your gain as it is, gain will be there. Okay, now means a takeoff point you have to show here. Okay, then this is your R of S, obviously this is your C of S will be there, and here what it comes, just exactly simply G it comes, simply G it comes. In previous rule we have seen, okay, it is 1 by G, no, it is simply G, means that if the takeoff point is there after the block, if you shift that block to the before, simply it will be simplified like this. Okay, simplified like this, like this. This one you have to remember, this rule number 7. And then next rule number 8. What is rule number 8? Okay, what is rule number 8? Rule number 8 is nothing but adding of multiple blocks. Adding of multiple blocks means that if you have, let us say this is 1G1, okay, you have another block, some G2, these two are added here, these two are added here. Likewise this is your C of S. Okay, let us say these are the inputs. Your input may be one input or two inputs or multi inputs can be there, not necessarily single input. Sometimes two inputs will also be there, okay, or sometimes they will be tied together and simply they will give R of S. Okay, likewise, so it could be anything. So this is your C of S. Okay, so let us say this is plus, or this is plus or minus, or sometimes this could be also plus or minus, whatever it is. So two blocks we are adding here, means summer point. So the correspondingly it will shows like this. Okay, so means then the resultant will be like this. Simply it is very simple, it is R of S and then C of S. Okay, then it is nothing but G1 plus or minus G2 you can write, because okay, because if this also plus, this is also plus, then your result will be G1 plus G2, and if it is plus, G1 is going to plus and G2 is minus, then your result will be G1 minus G2. Or otherwise, if it is plus then it is minus, then your result will be G2 minus G1. Likewise you have to simplify or you have to reduce. This is the rule number 8. This is the rule number 8. So these are the very important rules normally to be applied in order to find out the transfer function using block diagram reduction method. And one more thing I want to explain here is that simply you remember that if the problem is given and is asked you to find out the transfer function using the block diagram reduction, remember that only two points will be there. One is summing point will be there and another is takeoff point will be there. These are the 2 points normally we have in the block diagram, given block diagram problem. And one more thing we have, what we have to remember is that, so we know that summer point as well as the takeoff point. What are the combinations we have seen? Sometimes the summer may be before the block or sometimes after the block, or sometimes takeoff point could be after the block or otherwise before the block. Okay, then as per the convenient, as per the simplicity, in order to obtain the transfer function, we have to see the we have to suitably, we have to reduce that by applying these rules. That's all, very simple, very simple. Okay, so these are the basic rules normally, and if you, these we have to remember. So with this I conclude this lecture, and in subsequent lecture I will explain you that with the help of these rules how a block diagram can be reduced and thereby how the transfer function will be obtained. That we will see in the subsequent lecture. Thank you very much.